Welcome back, guys. We are continuing on with our math lessons today. Looks like we'll be doing this for a little bit longer than we had anticipated as well. So I get to enjoy this for about another month, and we'll see how much longer after that. Okay. I do want to let you guys know the answer to last time's trivia question was Drake and Josh. So my favorite TV show in 6th grade was Drake and Josh. It wasn't too long after that it was kind of replaced, I guess. I started falling in love with some other shows such as The Office and Scrubs, which Scrubs is on Hulu if you guys have. It's a pretty funny show as well. But The Office, hands down, is my all-time favorite now. But Drake and Josh was when I was in 6th grade. Some other ones I enjoyed from Nickelodeon, Fairly Odd Parents was a good one that was up there. I think there was some show called Zoe 101, Ned's Declassified, like Survival Guide, something like that. All That was another good one. Rugrats, Cat Dog, Rocket Power. So I had some good old favorites. Today, your trivia question is going to be dealing with kind of like birthday sweet treats. So when I was really young, my parents and I discovered I'm not a big fan of cake. Didn't really like birthday cake, especially. So they had to come up with something else, some other sweet treat for me to enjoy for birthdays, things like that, celebrations. So I want to know from you guys, what do you think I had for my birthdays that kind of started around 6th grade instead of a birthday cake? And then I want to know what you guys like to have as a sweet treat for your birthdays. Go ahead and take a moment and answer that for me. So my answer to this question is, there's actually two possible answers I'll accept. One is a cookie cake, hands down, chocolate chip cookie cake. Not a lot of icing on it, but just normal cookie cake is good. And then I also enjoyed in 6th grade ice cream cake. So either one of those sweet treats is what I liked in 6th grade for my birthday. I guess, yeah, for my birthday. So we'll go ahead and dive into our next section here, topic 11, which is reflection. Now, all of you have dealt with reflection before in last year in 5th grade when you took 6th grade content. We're going to kind of review a little bit today, but go farther and challenge you a little bit. So we're going to go back to this client's house, just like we did the one with the fireplace. For whatever reason, it's been moved on the outside of the fence, translated there. But now we're going to reflect this grill. Okay, so we want to know, the client wants the grill reflected to the other side of the patio. Okay? So the architect flips the placement of the grill over a vertical line segment dividing the patio. So here's this vertical line segment. Okay? And we're going to call this line segment the line of reflection. Okay? It's what we're going to reflect this grill over to put on the opposite side. So that's the same distance in the same spot, just on the opposite. Recall that a reflection, or also sometimes known as a flip, is a type of transformation. Remember, a transformation is changing the position, size, or shape of a figure. And in this case, the reflection is going to flip a figure over what we call the line of reflection. And the reflected figures are the same distance from the line of reflection, just on opposite sides. So this grill is going to be a specific distance away from this line. Well, that's a bad arrow. And it's going to be the opposite, or the reflection is going to be the same distance from that line of reflection. Here's the example of drawing out. Okay? Notice how the original placement of the grill has now been flipped to the other side, but it's the same distance from that line of reflection. Also take note, just like with a translation, we are only moving the position of the figure in the image. Okay, we're not changing the shape or the size of it. We're just changing the position, or sometimes known as the orientation of that figure. So let's look at a few examples here. So we have polygon A, B, C, D, E, and it has vertices of A, -5, 2, B, -5, 4, C, -4, 5, D, -3, 5, and E, -3, 2. And we want to graph, which we already have here, graph that and its image, A prime, B prime, C prime, D prime, and E prime, after reflection across the x-axis. So if you recall last year when you did a bunch of reflections over the x-axis and the y-axis, you took a point, found out its distance from that axis, and created that reflection. You're going to do the same thing here, just with a figure. Okay? Well, we can start in order if we like. So let's look at A. We want to know how far away A is from the x-axis. Okay? Well, actually, if you look at the y-axis, it tells you. Okay, here's a little sheet here. So you want to know how far away it is from the x-axis. Well, it's actually 2 units away. 1, 2, 1, 2. So on the opposite side of the x-axis, it also has to be 2 units away from it. So 1, 2, be down here. Notice that A was at 2, and A prime is at -2. The y-axis is going to tell it all here, guys. So let's see how far away B is from the x-axis. B, if you look over at the y, is 4 units away from the x-axis. So on the opposite side, it has to be 4 units away, down to -4. So here's B prime. My B's, man, I'm so big. All right, so C, how far away is C from the x-axis? We would see that it is 5. So on the opposite side, it would also have to be 5, and we go down to -5. So here's C prime. D is also going to be 5, just right next to it. So here's D prime. And then E is going to be 2 units away from the x-axis, down to -2. And then if you had paper, or you could draw, I mean, I'll give it my best try to draw the line figures here. Okay, this would be the reflected, I need to put E prime, the reflected image of the figure. Okay, notice, and here's a much better drawing of that, notice that when you reflect, all you did was move the position of the figure in its image. You're not changing the length of any of the sides, you're not changing the angles, just like you did with translation. The only thing that's happening is you're changing the position. The additional aspect that's happening is you're changing the orientation. Notice how on this side, okay, like B and C are facing up, it's, you know, the angles kind of appear on the top left side here, or the diagonal, but down here it's on the bottom left. So that's what it means. We just kind of like turned the image. But it's still the same size and same shape, just in a different position and orientation. Okay? I want you guys to take a moment and look at parallelogram A, B, C, D, and parallelogram A prime, B prime, C prime, and D prime. And I want you to come up and identify with what you think the line of reflection is that is taking this figure and creating this image on the other side. Okay, go ahead and take a moment to figure that out on your own. Okay guys, for this one, the line of reflection is the y-axis. Okay, I'll walk you through how we would actually get that. Okay, to find a line of reflection, okay, the point of the figure, which in this case is A, and the point of the image, A prime, need to be the exact same distance from the line of reflection. Okay, let's go ahead and look at this. So A is 1, 2, 3 units away from the y-axis, and A prime is 1, 2, 3 units away from the y-axis here. Okay, you can also find the distance between them. So the distance between A and A prime is 6 units. Okay, well, the line of reflection is the middle or the center between those 2 points. So those have to be the exact same distance. This has to be 3, and this has to be 3. They have to have the same distance. So since this is a total of 6, you can actually divide that by 2 and get 3 on each side. You can do the same thing with D. So notice that the distance between D and D prime is 2 units. Well, half of 2 is 1, so you know that the distance has to be equal, and each one of these have to be 1, which makes the point fall right on the y-axis. Same thing with B and B prime. The distance between B and B prime is 12. Half of 12 is 6. So if you were to count 6 away from B and 6 away from B prime, it would end you up on the y-axis. And the same thing with C and C prime. They are 8 units away. Half of 8 is 4. And that puts you right on the y-axis as well. If any one of those points don't put you on that same line of reflection, this will not work. Okay, so your line of, this is a bad line, guys. Your line of reflection in this case is going to be the y-axis. So I'm just going to abbreviate line of reflection is the y-axis for this one. Okay. Now, moving on, we're going to identify the line of reflection here. I want you guys to take a moment and see if you can do that on your own first. Okay, guys, to find the line of reflection, just like you did in the last one, okay, you need to find the distance from each of the points in the original figure to its image. So the distance between B and B prime, okay, when you count it out, is 4. Well, half of 4 is going to be 2, so you know that the distance to the line of reflection has to be 2 from each one. So you go 1, 2, put you here, and 1, 2, put you right here. Keep on going with it. We can look at C and C prime. The total distance between C and C prime is 6. So you know that the distance from each one to the line of reflection is going to be 3. 1, 2, 3, and 1, 2, 3. You could continue doing this with the other ones, such as A and A prime. It would land you here, and D prime, which would land you here. So then we have to create this imaginary line of reflection because it doesn't actually fall on the y-axis or the x-axis. So you would draw, and I'm going to try to do my best to draw as straight a line as I can, all the way down, until you run into one of the axes. In this case, we run into the x-axis. Well, this point we need to identify. Here's our origin. This point is actually -1. So this line of reflection runs through -1 on the x-axis. So this means that our original figure was reflected over this imaginary line on the x-axis, actually. It runs through the x-axis and creates this image. So our line of reflection is x equals 1. I don't know if teachers in the past have told you this before, but all of these grid lines actually have a meaning. This would be -1 running all the way up. This is -2 running all the way up, -3. And the same thing on the y-axis. 1, 2 all the way across, 3 all the way across, 4 all the way across. And that's where we can get these line of reflections from. Okay? Let's keep going on. So, quadrilateral KLMN has vertices K26, L38, M54, and N32. It's reflected across the x-axis, resulting in quadrilateral K prime, L prime, M prime, N prime. I want to know from you guys, what are the possible coordinates of point N prime? So to figure this one out, you have to realize you're reflecting across the y-axis. Anytime you're reflecting across the y-axis, the x-axis coordinate is the one that changes. So in N, we are going to change the sign of the x-axis coordinate, which is 3. So in prime, the sign would change to make this -3, and we're going to keep the y-axis coordinate when we're flipping over the y-axis itself. So n prime is going to be -3, 2. So it's kind of opposite here. When you're reflecting over the y, you switch the x coordinate. Reflecting over the x, you switch the y coordinate. Last one here, guys. I want you guys to go ahead and take a moment and see if you can figure out this one on your own. Okay, guys. So notice in this case, we're reflecting across y is -2. To figure this one out and figure out what b prime is going to be, you have to imagine that line going through -2 horizontal all the way across. I'm going to take a moment and draw a graph for you. So this is the line that we're going to reflect over. Since we're reflecting over this -2 on the y-axis, we're actually going to change the y-axis coordinate. So originally it was 5. We have to figure out the distance between 5 and -2. Go ahead and take a moment and see if you can figure that out. So in this case, the distance is going to be 7 units away, which means now going the opposite direction, we would have to find 7 units away from -2, which is the line of reflection, and that would give us -9. So our point is B prime is -2, 9.